Hello from UCLA SolidWorks Student Leadership Program. In this video, we will be walking you through how to construct parts from drawings. This will be very similar to what you can expect to see in the CSWA exam. So, this is our first part, and you can see that it can be built using only two features. The first feature will be box extrude based off of this sketch, and it will include this 12mm hole. The next feature will be an extruded cut, which will make this little section of the part, and that cut will be made using this view. So let's begin. The first thing that we want to do is make sure that our units are correct. We can see here that it is indeed in millimeters, like the drawing. So then, we start a sketch on the front plane, and we will be outlining that profile view to extrude. We want to make sure that this line is vertical, as we can see indicated by the yellow box of the vertical line. And we dimension this to be 75mm. And then next, we just complete the little staircase drawing. We want to make sure that we get our lines to be either perfectly vertical or horizontal. The sketch is now closed, and we can begin to dimension each of these lines. This will be 60mm. This will be 12mm. This will also be 12mm. And this last horizontal piece will be 20mm. This distance between these two lines will be 12mm. And this edge over here will be 30mm. And then the distance between these two lines will be 20mm. And now we can see that our sketch has been fully defined. Now we can add our little circular cutout. The diameter of the circle will be 12mm. And we can use smart dimensions to dimension its position. It will be 16mm from each of the edges on this right hand side. And now our sketch is complete. We'll extrude the sketch by 28mm. And now for our second feature, we can create a sketch on this face. All we will need will be a corner rectangle. We'll snap it to this corner and to this line. And then we dimension this distance as 20mm. And this will be an extruded cut. First, we want to flip the direction of the cut. You select through all, and then we also flip the side to cut. So now the part's geometry is complete, and we add a material. The material here is aluminum bronze. You can either scroll through this menu or just search it up in this handy search bar. After you finish a part, make sure to double check its mass properties.
Well, that was our first part down. Now we'll be getting into our second part. So this part is a tad bit more complicated. Let me zoom out a little bit. It's basically called a pipe fitting. So this might go on the end of a pipe, it might secure the pipe. And basically you're given a couple of views here. So you're given a top view, you're looking at it top down. You're given a side view, a kind of actually cross-section view, as we talked before in our drawings video. Check that out if you haven't already. And a sort of isometric view in the bottom left-hand corner. Things to note is here it states your unit system, so millimeters, grams, and seconds. Then decimal places too, you don't really need to worry about this since all the dimensions they give don't actually have decimal points. Part origin arbitrary, that just means that you can place your origin wherever you want it to be. Your first part can go wherever. More specifically is PB. So as Willy did, he changed the material to, I believe it was some sort of copper alloy, some sort of metal alloy. In this case, it's going to be plastic. And then underneath that, they give you the density, 970 kilograms per meters cubed. When you're selecting the material in SOLIDWORKS, it's good practice to just check that the density at least matches the material, so then you don't select material that has a similar sounding name that has actually completely different material properties. And then underneath you'll see some letters. A is equal to 38, B is equal to 12, C is equal to 3. So these are actually global variables, and we'll be getting into how to create those in SOLIDWORKS inside of a part in a moment. And you're going to need to create global variables instead of creating regular dimensions where you just put in a number, because in part B and part C it asks you to update the global variables using different values. So if you just have dimensions, you have to go manually through and change all of your dimensions numerical values, which is kind of time waster in my opinion. So it's just much more time efficient on the actual exam to just create global variables for these numbers and then change the global variables themselves. So just looking from, I guess, a sketching mentality, what we're going to create first is this big kind of cylinder in the middle. Then we'll be creating the two outside circles, and then we'll be creating this kind of region over here on both sides where it has this kind of weird shape. And then also has these little cutouts inside. And then if you look on the side view, you'll see a little bit more dimensions on how everything is horizontally spaced out. So you see that the centers of the two outside circles, which you can see up here, this is outside circle 1, outside circle 2, and this is the same thing here and here. They're spaced apart by a times 5, so a as before is the global variable, and I'll show you can actually put this directly into that dimension itself, and SOLIDWORKS can automatically do the math for you. You can see that the outer diameter of the big inner cylinder is a times 3, and you also see some stuff here. This is specifically for this kind of weird looking region. The bottom of the cutout here, this kind of weird cutout, is 9 millimeters away from the bottom, and then C, the global variable, is the depth of that cutout. And then you also get the diameter of the little cylinder on the inside, and then on the right over here, you're getting the height of the big cylinder. Actually, if you add up this dimension and this dimension, you get the overall height of the cylinder. And then the one last dimension that we haven't covered yet is this B. So the width of the cylinder walls is B, and same with the other cylinder. And sorry, there's one more dimension, and the last dimension is you have these kind of rounded edges that the radius is C, and your inner kind of weird cutout thing is space C from this edge, this edge, this edge, and this edge. So that's kind of an overview. I'm just kind of talking through the drawing, and now we'll actually go into SOLIDWORKS and create a new part. So we're going to File, New, we want a part. And so this is what you see, of course, when you just first open up a blank SolidWorks part. Things to note: in the bottom right hand corner you'll see MMGS. This is the unit system that we're working with. And Willy in his part, he changed the material last. I prefer to do it first just so I don't forget to do it later. It's pretty easy to do. You just go to material, click material, right click on material, click edit material, and in this case we're looking for polybutadiene, so PB, and the density here is 970 kilograms per cubic meter, which is which checks out with the drawing. So we're just going to click apply and click close. So now you can see on the left hand side it says polybutadiene. So as stated before, the first feature that we want to create inside of our part is going to be that big inner cylinder. So looking back at the isometric view, you can see that everything just kind of up, so it makes sense to create your sketch on the top plane. So we're going to do that. So we're going to click top plane, and you go up and it says sketch, so click sketch. And we're going to go ahead and create 2 circles. So circle 1, circle 2 inside circle 1. So looking back at our drawing here, we can see that the thickness of the wall is B. So we can first put that in. And here we have, so if you put a dimension between these two, you can see that it pops up wanting you to enter in a numerical value, or so it seems. But as mentioned before, we want to use a global variable instead. So this global variable is B. So in order to enter in a global variable into a dimension window like this, or many other windows in SolidWorks, you would press equals, so the equal sign, then double quotes the name of your variable, in this case B, and then end it with another double quotes. And you'll see this little globe appear with a little plus in the upper right hand corner. And then when you press enter, then in this case I haven't yet created the actual global variable named B. So it says create a global variable named B, so yes, we want to create it. And in this case, B updates to the value that I had before, which is this random really long number. We'll actually go ahead and change that right now. So we're just going to go ahead and click OK, exit, and okay, so B in this case is shown to be this random number. We instead want B to be 12, A to be 38, and C to be 3. So we'll create B is 12, A is 38, and C is 3. 38, 12, 3. Yep, it works. And then we click OK. So in order to access this equations window, you just go into the upper right hand corner, search bar, just click enter in equation, and then it should be the first result, and it'll pop up with this window. And then click OK. And you can see it instantly changed the width between the two circles to reflect the new updated value of B. So now we can go back into the sketch and finish defining it. So the next crucial dimension that we need is the outside diameter of the outside circle is A times 3, so we're going to go ahead and just do that. So A times 3, A times 3. There we are, and now you can see in the bottom right hand corner that says fully defined. So yeah, that's good. Then we need to create an extruded boss / base. And as I mentioned before, the height of this big cylinder in the middle can actually be found using 38 plus 25. So in SolidWorks, you can actually enter this in directly to the dimension. So you can say 38 plus 25, press enter, and then automatically evaluates it for you. So just pretty standard, you just have a cylinder in the middle, and now we're just going to be creating the 2 circles on the side. So we're going to go with another sketch on the top plane, zoom out a little so you can see more, and so we're creating these circle on the left, circle on the right. So yeah, we'll just go ahead and create that. So we have this is forming the left cylinder. And I'm just actually going to create everything only on the left hand side, and I'll just mirror everything to the right later just to save me some time. So we can see from this dimension in the bottom right hand corner, it says the diameter is A times 2/3. This is the inner diameter, so we'll just go ahead and put that. So we're going to select our we're going to select our inner diameter, and again, equals, then quotation marks, your name of the global variable, end it with quotation marks, and then multiply, in this case, by 2 divided by 3, or 2/3. Press enter, it automatically evaluates, and press the check mark. Then you know that all widths of the cylinder are B in this case. So then you select outside circle, inner circle, then you enter in B. Oops, I forgot that. Okay. Okay, that's all fine and well, but what is the distance to the center, or to this kind of the central line of this part? So first, what I'm actually going to do is I'm going to mirror this left set of circles to the right, and then I'm going to create the diameter the dimension in between them. So in order to mirror, as usual, you just create a center line, or any line for that matter, and then you select mirror entities. We want to mirror these two entities and mirror them about this. Okay, that's good. Now we're going to be creating our kind of spacing them out in the horizontal sense. So the center of this set of circles is A times 5 away from the center of this set of circles. So we're just going to go ahead and dimension that in. This point, that point, and set it to A times 5. Okay, nice. So it still says underdefined. Oh, okay. Looks like I just needed to create a center line through it, and then SolidWorks kind of just corrected this own mistake. So yeah, now we have these two circles on the left and right hand sides, and now we can just extrude them upwards. And of course we don't want 63 millimeters, we want 25 on the right. So this is the height of these two cylinders, 25. We're going to go ahead and put that in, 25. Press enter. Press OK. And it's starting to look like the part is specified in the drawing. But next what we need is the kind of weird shapes on the left and the right here that connect these two cylinders with the big cylinder in the middle. So in order to create these, we're actually going to use a pretty simple sketch. It's just actually 4 lines, each tangent to these circles. So as you can see right now, you can kind of just move it around this circle, move this along, but we want it to be tangent. So you select the line, you select the circle, and then you click tangent. Press OK. I'm going to do the same to this one. So this is one line, and I'm again going to use symmetry. But I'm just going to create a line, make a tangent, this one tangent. Okay, they're both fully defined. Good. Now we're going to mirror both of them to the other side. So mirror entities, select those 2 lines, select the center line, and automatically goes to the other side. But then now you can see it's not a closed sketch, right? It's still open. So what we need to do is that we need to convert a couple of entities. So these 3, we're going to click convert entities, automatically makes them, projects them onto the current sketch plane. And then we're going to trim away everything that we don't need. So that would be this we don't need, that we don't need, that we don't need, that we don't need, this we don't need, and that we don't need. Okay, so now we have a fully defined sketch. It's what we want it to be. And we're going to go over to Features, Extruded Boss Base, and what height are we going to use? Well, if we refer back to the drawing, we can see that the height is simply 9 plus C. So actually, even though this isn't the standard dimensions window, you can actually insert a global variable into it. So you want C plus 9. So you press enter and it automatically evaluates. Awesome. So now if you look from the side perspective, all we're missing is just these little cutouts in the middle. So in order to create these cutouts, I'm going to create another sketch on top of these little connecting portions that we just made. And we're going to use the offset entities tool. We're going to select this edge, this edge, this edge, and this edge. This is not actually the full outer circumference of the circle, it's only the part that's been intersected by the lines that I've already selected. So we're going to select that, click Offset Entities, and actually this is, to my knowledge, the only box where you cannot enter in a global variable. So in this case, we're just going to enter in, say, 3, and click check mark. Oops. You actually have to reverse it, and it comes out with it. Now we have true dimension here, so we can go ahead and actually input the value of C, which evaluates to 3. And next, what we're missing is these little actually sketch fillets on these sides. On the sides, you can see that they are the radius. There's 8 of them, and the radius is C. So one here, 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 one here. So we're just going to be creating those right now. So click the sketch fillet icon and just select 2 adjacent lines, arcs, what have you. And then we're just going to change it to 3. And I find that also if you input in C, it doesn't really create a global variable reference. So I'm just going to enter in 3. And we want to create another one here. And another one here. And another one here. Okay, now we can use the power of relations. Actually, first we're just going to make one of them equal to the value of the global variable C. And we're going to use the power of relations to make everything equal to each other. So we're first going to actually delete these dimensions. Okay, maybe we can't delete those dimensions. Okay, so we just go ahead and type in equals C. Just going to copy that. And I didn't mention this before, but you know if a dimension has the equation attached to it if it has this little sigma sign in front of it in red. So now we have everything on one side, now we just need to mirror it to the other side, so we'll go ahead and create a center line. And we'll mirror everything to the other side. Press check mark, and this is a cut, so we're going to use extruded cut. And how deep is the cut? Well, it says right here that the cut is C deep. So we're just going to enter in C equals C. Press the check mark. And there it is, that's our completed part. So as you can see, the isometric view looks exactly the same. We've used all the dimensions that are specified in the drawing. Some of them we had to combine, such as the 38 and the 25. But yeah, for the most part, quite simple and according to the drawing. You can go to evaluate, and then you go to mass properties, and then it will output the mass of your part. So you can see that the mass is 346.49 grams. This is calculated according to the density and the volume of your part. So the density is given in the mass material properties, as you saw in the very beginning where I specified that, and it just calculates the volume of your part. So then it comes out with the mass in grams. So next, this is actually just part 1, right? Part A. But part B has you updating these global variables to a value that's different and then finding the new mass. So in this case, it wants you to change A. In this case, it wants you to change A to 35, B to 10, and C to 2. So we'll see how that evaluates. So you just press OK. Then it'll automatically rebuild it. Feature sketch 1 has warning. Okay, let's see.
You changed A to 10 and B to 35 and not the other way around.
Oh. Good catch. Very good catch. Oh, sorry, wait. A to 35. Okay, 35. I should have probably made it in alphabetical order. Okay, 35, and then we click OK. And then I need to move the rollback bar back down. Okay, awesome. So this is what the updated geometry looks like, and then that's for part B, and then you would find the mass in part B. And then lastly in part C, it wants you to change A to 32, B to 6, and C to 2.5, so we'll go ahead and do that right now. A to 32, B to 6, and C to 2.5. Click OK, then the part automatically rebuilds itself. And yeah, this is part C.
Alrighty, this is our last part for the video. So as you can see, this part wants us to make a gear. The first thing we're going to do is make a circle, and you can see I've already done that in SolidWorks. And this circle is going to be corresponding to this guy right here, the circle. And this circle has a radius of 8, and this is kind of important. This is one of those times when they're trying to trick you. They're not giving you the diameter, they're giving you the radius. So when we go into our smart dimension, and we make our dimension, we got to take the 8 into account. We're going to make this a diameter of 16, because that's twice 8. Okay, and then we're going to go back out. Right now we're going to make this little key, which is just to help the gear turn if it was in real life. And we know that the top of the key we can see is 10 millimeters away from the center of the gear. So we're going to go back into SolidWorks. We're going to make a line, and we're going to say that it is 10 millimeters away. All right, now we can go back to our drawing. We can see that the width of that line is 3 millimeters. So let's do that as well. And now you can see it's off center, and I can move it around. So what we want to do, you're going to take that middle point, the midpoint, you just click on the line, just slowly move your mouse over the line. You can click the midpoint, click the middle of the circle. We're going to get our relations tab over here. We're going to say this is vertical. So now we have this exactly over the middle of the circle, and we can just take some lines. So we can go down to the circle, down to the circle, and cut away this. There you go, we have our circle and a little key on top. So next, we're going to make this bigger circle, right? And that one does give us a diameter, so we're going to use a diameter of 28. So we can go into here, make this a diameter of 28. All right, and there you have, that's our little middle part of the gear. And that's about all we can get off of this part of the drawing. There's no other dimensions here, so we're going to move on to another part. And the best part we can move on to is this big drawing here. What is our next thing? So we've made this circle. We can do maybe this outer circle, right? How do we figure out how big this outer circle is? Well, it doesn't give us a diameter somewhere, right? We don't have a dimension that goes like here. So we have to come over here to look at this. And we can see we have our variable A right here. And that's going to be the way we find out the diameter of this circle here. You probably see that A is going from the top of a gear tooth to the bottom of a gear tooth here. So we don't exactly have the diameter. So what we're going to do is we're just going to make a big circle for now. Since A is 108, we know that this circle is going to be pretty large. This can be arbitrary for now, and we're gonna start making the first gear tooth, and this will help us get our dimension for the big circle. Okay, so we're gonna do kind of the same thing we did for this key down here. We're gonna make a line, and we're gonna say that this line, the middle of this line. We're going to say that the middle of this line is vertical to the center of the circle. We're going to give this some gear tooth looking diagonal lines. And if we look over here, we can see that the width of this is going to be 4, and this angle here is going to be 40. So let's do that real quick. We can say this is going to be 4. We could say that the angle between these two guys is going to be 40. And that looks a little weird, I know. That's just because there's not enough relations. Okay. Next, we're going to make a construction line, and this will make our gear tooth look a little bit more like a gear tooth and not like a weird, I don't know, saw blade maybe. We're just going to make a line there. You don't have to define it because it knows that this length is already 10. And we're going to say that the angle between this and this. It's going to be half of 40. That's 20. There you go. And now we can make a point up here at the top of the circle. And going back to our drawing, we can see that this dimension from the top of our gear tooth to the circle is 6. So we can say from here to here is going to be 6. Okay. And now we have that. Okay, we're going to do a circular sketch pattern. We're going to come down under the linear sketch pattern tool. So we're going to come under the linear sketch pattern tool. We're going to select circular sketch pattern. And we're going to select an entities to pattern, the gear teeth lines, right, that we made. And this is important, the circle. This will make it so that the gear teeth are connected to the circle, so that when we make our dimension later from the top to the bottom, it's going to keep it on the circle and not go crazy. And you can see here I have this blue line going from the middle to here. That's because I have this dimension radius option checked. You don't want that. That's not helpful for us. So we're going to uncheck the dimension radius. We're going to up the count to 24 because there are 24 gear teeth based on the number of teeth, right? B is the number of teeth, and we have B up here is 24. So come in here, up that to 24. It knows since I selected the circle that it wants to rotate around this point. We're going to say click, and we have a bunch of gear teeth. That's good. So now we can come to the smart dimension, use that, we can say this is 108, and boom, we have the right size. And the way I knew it was 108 is because A is equal to 108 over here. Now that we have that, we can start naming some variables, and these are going to be important later too, because we have a couple different parts of this, right? We have part A, which is all this, part B, which is all this, and part C here. So to help us make sure that we can easily edit that stuff, I'm gonna first, we're gonna select this, say this is equal to A, and you can see this little global up here, and it's gonna say create global variable, and I'm gonna say yes, do that. Okay, so now I have a global variable called A, and you can see in this equations folder pops up, and this wasn't here before. But if we open up this, we can see that I have A is equal to 108. And this is going to be helpful later. I'll show you why then, but it makes it really easy to change what A is, and that will be helpful for the later parts. The other part you can see is this 24 here. That's the number of teeth there are. If you remember, B is equal to 24. So instead of having this be, say 24, I'm going to change it to saying B, and it's going to say you're overriding value text, and it doesn't really matter. But now I have B here, and I can change it however I want, right? Okay, now we're going to keep working on our drawing, and we have a little bit more to do before we can start extruding stuff. So we're going to get to our last variable C here and erase some of this stuff so it's easier to see. Okay, so we have a couple things. So first off, we know that from the outside diameter circle to the inside diameter circle, we have a dimension of 6.5. So we're going to make another circle. This is going to be 6.5 millimeters away from the outside. We have that circle. And then going back, we have two dimensions here, C, right? C and C. And that's the dimension from this inner circle to this inner circle, right? So we're going to get two more circles. We're going to do one here and one here, and that's going to be equal to C, right? So we're going to come into here. We're going to give that a value of, let's say 5 for now. But let's come back. We say that, oh, C is 2.5. So let's actually make that 2.5, right? Double click on that. Say this is 2.5. And then we're going to double click on it again. This is equal to, you have to do the quotation marks C. We're going to say create new variable. And now we have that C, from the equation, C is equal to 2.5. Okay. And then instead of making this, like also doing 2.5 here, we can say dimension here. Say this is equal to C. And we're going to get this pop-down menu, or this drop-down menu, and it's going to say C is 2.5. We're going to say, yes, this is also C. there you have it. We have both of these equal to 2.5. Okay, now all that's left is to do these spokes. And this should be pretty simple. It's very similar to the way we did the gear teeth and the rotations. So what we're going to do is just come up here. It's a little messy. So we're going to come up here, we're going to make a line going from the top to there. And from here to there. You don't need to make it like perpendicular or anything. We're going to fix that right now. So these have to be parallel. So now that, and then we're going to say these are also always going to be equal length. So now if I move one, they both move. And then I can say that the dimension between these two. And now what's the dimension going to be, right? We can look here, where is it? Oh, it's right here. Wait, it's C times 2. Okay, so what we're going to do, we're come here, we're going to say this is C. We're going to say yes, this. And I get a space, multiplication symbol, 2. And that should give us 5. And is that correct? 2.5 times 2 is 5. Very good. Okay, now we have the spoke of our gear. Fantastic. So let's come back into the circular sketch pattern again. And we're going to select our spoke lines and inside and the outside. And it knows that. And we're going to say this is 8. And this is 8 because we have 1, 2, 3, 4, 5, 6, 7, 8 spokes. Say yep. And there you have a fully defined gear. So we're going to say exit the sketch. And then we can do an extruded boss base. This is where we start making that part. 3D. So we're going to choose sketch 1. And the best way to do this part in particular, I've found, is to use it as a midplane, because we have symmetry across this axis in the middle, right? We have 1 millimeter off here, and 1 millimeter here, 2 millimeters, etc. Right? So we're gonna start off doing the largest dimension. That's gonna be this guy right here. Right? So you can see it goes on both sides. It's symmetrical across this plane in the middle. And then the other part that is 18, you can see from here, 18 is this dimension. This is a little less, this is a little less, these are definitely less. But this guy in here, the middle circle, that's going to be more, right? So we'll also select this. We're going to change this dimension to 18, and that's going to be the total length, right? It's not going to be 1/2, it's going to be the total. We'll say yes. And now we have 2 little circly thingies. So we're going to do another extruded boss base. We're going to drop down this menu here. This is the way we get back to our sketch, so we can select it again. And I'm going to do the insides now, because I don't like having multiple parts. And of course, we're going to do midplane for all this. Just take 2 seconds, select all of them. And so now we know that it's 1 millimeter off both sides. So what it has to be, right, is 18 minus 1 minus 1, so 18 minus 2, so it's 16. Oh, and if that happens, you can just go into here and click Edit Feature and select another region here. Oop. And now we have spokes all connected to the middle part. We have 1 solid body instead of 2. So now we're going to do the extruded one more time. Select the sketch. I'm going to select all of these guys. It's going to be a little time consuming. Okay, you can say this is a midplane again. And these guys are 18 minus 2 minus 2, so 18 minus 4, it's going to be 14. Right, that looks about right, doesn't it? And boom, you have a gear. But wait, there's a tricky thing, and this will get you, and it got me the first time I was looking at this one. You can see we've got this last little dimension that we haven't used. and that's the radius of this fillet. And it's easy to miss this little fillet. And there's 32 of them, so it's going to take a little while to click all of it. But there's no other way to do it. You can't fillet it in the sketch because it doesn't like straight lines coming to a point with a circle. So you have to select this edge here for every single one. So there, 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 there. You have to do it for all of these holes. So let's do just that. We're going to come over here to our fillet. We know that this fillet is going to be of a radius 2. And now we're just going to start filleting stuff. Okay, now you can see I have all of my edges selected to be filleted. There are 32 of them. Edge 32. Say yes. And boom, you have completed gear. And the final step in this process for the test, you're going to have to, of course, get the material. So we can see that the material is cast carbon steel. We're going to take note that the density is 7,800 kilograms per meter cubed. So let's go here. We're going to say material. We're going to say edit material. And bring this into here. And then we're going to say cast carbon steel. Cast carbon steel, there it is. We can see that the mass density is 7,800 kilograms per meter cubed. That's right, so we're going to apply that. Change the code a little bit to show you that it actually happened. And now if we come over to the Evaluate tab and click on Mass Properties, we should get a mass over here. And the answers should be in the description. And then finally, if you ever needed to change the equations, you just go into here to the Manage Equations, you pop this up. You have your global variables here, and you can just change these numbers. Alright, thank you for watching. That's been our video for today. If you would like to download the PDFs that we used in this video, they're in the description. Also in the description are the links to the Slack channel and website if you are interested in exploring options for taking the CSWA test or are just interested in what we do in general. Thank you very much for watching and have a great day.